Hello student. In this session we will solve the numerical which is based on complex algebra method, and by using complex algebra method we will find out the velocity of the mechanism. Okay. So here is the statement of the one numerical that we will solve. And IC engine mechanism. What is meant by IC engine mechanism? IC engine is the slider crank mechanism. So they given that there is a slider crank mechanism. The crank radius is 50 mm. Crank radius. Okay, crank radius, that is, we will consider crank radius is r and it is equal to 50 mm. If we write this in a meter, that is 0.05 meter. And connecting rod length is 200 mm. The connecting rod length is represented by L and it is equal to 200 mm. That is equal to 0.2 meter. The crank is rotating at the 100 radian per second. The speed of the crank is 100 radian per second. What is this? That is omega of the crank. Omega of the crank is equal to 100 radian per second. At the particular instant of the crank is at 40 degree from the TDC. They given the position of the crank from the TDC, that is theta is given, that is equal to 40 degree. And they what they ask, for this position find the velocity of the piston by complex algebra method. They ask to find out the velocity of the piston by using a complex algebra method. We can solve this numerical by using analytical method, but here they specify that to find out by complex algebra method. Okay. Before going to solve, we will draw the mechanism. Okay. So this is my crank. This is my line of action, and this is my piston. Okay. I will mark it as suppose A, B, and point C. So what are they given? We will show you in this diagram. Okay. Now, if we draw here an imaginary axis and real axis, then this is my imaginary axis and this is my real axis. Okay. What they given? Radius of the crank means this is the R. Okay. This is the R. We will give the notation to each link. We will mark this link, that is link AB, as by R2 bar. Here is link 1, that is R1. The fixed link we will mark as a R1. Link AB we will mark, that is R2 bar. Link BC we will call as the R3 bar, and this is my link number 4, that is R4. Okay. Now they given that L. Here is the length. This is the length of the connecting rod. They given that omega, that is the speed of the crank is 100 radian per second. Means the speed of the crank. That is here is omega 2. This omega means this is our omega 2. Because we mark the link AB as link number 2, therefore omega 2 is equal to 100 radian per second. They given the theta is 40 degree, so this angle we will mark this as a theta 2. Here is also theta 2 is equal to 40 degree. Here is also this angle is 40 degree. Okay. Now we will consider this distance AC. We will consider this distance as x at any particular instant, or that for this angle is 40 degree. We will consider this distance is equal to x. This distance is equal to x, and they ask to find out the velocity of the piston. Velocity of the piston. Now if we apply here, if we apply closure loop equation here, then we will get AB bar plus BC bar plus CA bar is equal to 0. AB bar is equal to BC bar, AB bar plus BC bar plus CA bar is equal to 0. And if you write this is AB bar plus BC bar minus AC bar is equal to 0. And AB bar plus BC bar is equal to AC bar. Okay. Now, this distance AB bar, this length AB bar is equal to R2 bar. Therefore, AB bar is equal to R2 bar, and it is equal. If we write this in the form of complex algebra, then the magnitude of the AB, magnitude is length of the AB is R, so it is equal to R into E raised to R into theta 2. Okay. Similarly, BC bar is equal to R3 bar, and its the length of this BC is equal to L. This magnitude is L. Therefore, L into E raised to R into theta 3. We will consider what is theta 3. So theta 3 is this angle. This is theta 3. We want to find out this angle with respect to real axis in this direction. So therefore, this theta 3 is this is the angle and it is shown by diagram. Okay. Similarly, AC bar is equal to R4 bar into x into e raised to r into theta. A into x raised to r into theta. Okay. Here is theta 2 is, what is the theta 2 angle? Theta 2 is equal to 40 degree, theta 3 we don't know, and theta 4. Theta 4 means this angle made by this R4 with respect to real axis, and this angle made by this R4 with respect to real axis is 0. Therefore, theta 4 is equal to 0. If we put theta 4 is equal to 0, we will get e raised to 0. And what is the value of any? If we consider any number and if we take its exponential at 0, we will get it is equal to 1. Means if we take the 2 and if we take its power at 0, then its value is equal to 1. Therefore, this is equal to x. This is equal to x. Okay. Now, if we put all these value in equation this, suppose I will mark this as equation 1, then if we put this value in equation 1, we will get r into e raised to I theta 2 plus L into e raised to I theta 3 is equal to x. We will mark this as equation number 2. Equation number 2. Okay. The value, and what is the value of e raised to I theta 2? It is equal to r into cos of theta 2 plus r into sin of theta 2 plus L into cos of theta 3 plus r into sin of theta 3 is equal to x. Okay. We take the expansion of this term, that is e raised to I theta 2, and we will take the expansion of e raised to I theta 3. Okay. So it becomes r into cos of theta 2 plus r into
sin of theta 2 plus L into cos of theta 3 plus L into I into sin of theta 3 is equal to x.
We will take the I term separate and other term separate. Means complex we will separate here the complex number term and real number term.
So here R into cos of theta 2 plus L into cos of theta 3 plus I into R into sin of theta 2 plus L into sin of theta 3 is equal to x. Okay.
Now if we compare these both the sides here, if we compare these both the sides, then this term is equal to x and this imaginary number is equal to 0. Therefore
comparing imaginary term. If we compare the imaginary term, then we will get R into sin of theta 2 plus L into sin of theta 3 is equal to 0.
if we compare this x is real term and its imaginary term is equal to 0, and here is also this is the real term and this is imaginary term. So if we compare the imaginary term, then R into sin of theta 2 plus L into sin of theta 3 is equal to 0. What is the value of R? R is equal to 0.05.
0.05 into theta 2 sin 40 plus L is 0.2 into sin of theta 3 is equal to 0. So sin of theta 3 is equal to minus 0.05 into sin of 40 upon 0.2, and sin of theta 3 is equal to minus 0.1605, and if you take the inverse of this, theta 3 is equal to minus 9.35, minus 9.235 means theta 3, if we see
in this diagram, the theta 3 is minus 9.23, means this angle is minus. So if we want theta 3 in this direction, so it is
equal to 360 minus 9.235, and it is equal to 350.625. 350.765.
theta 3 is equal to 350.765 degree. Okay, here we got the theta 3. Okay, now what they ask in numerical, they ask to find out the velocity of the piston. They ask to find out the velocity of the piston. So what is the velocity of the piston? Formula for velocity of the piston is Vt bar is equal to dx upon Vt, where x is the displacement, and if we take the derivative of displacement with respect to time, then we will get the velocity. Okay, so x, what is the value of x? The value of x, we take the value of x from this equation number 2. So therefore it is equal to d by dt into r into e raised to I theta 2 plus L into e raised to I theta 3. Okay, so this is equal to r into d by dt
into e raised to I theta 2 plus L into d by dt into e raised to I theta 2. If you take the derivative, then you will get r into e raised to I theta 2 into I into d theta 2 by d3 L into e raised to I theta 3 into I into d theta 3 by dt.
Okay. Now d theta 2 is angle made by the limb 2 with respect to real.
If you consider suppose this is my mechanism, this is limb number 2, this is limb number 3. Okay. And here this angle is theta 2, here is angle theta 3.
Okay. So d theta 2 by dt is the angular velocity of this limb, that is omega 2.
So it is equal to r into omega 2 into e into I into e raised to I theta plus L into d theta 3 by dt.
d theta 3 by dt is the angular velocity of this connecting rod. So this is equal to omega 3.
So here L into omega 3 into I into e raised to I into theta 3. Okay. Now
And the expansion of this term, okay, expansion of this I into I theta 2, the expansion of I into I theta 2, if we take now, it is equal to
r into omega 2 into e raised to I into theta plus pi by 2
theta plus pi by 2
plus L into omega 3 into e raised to I into theta, here is theta 2, here is theta 3 plus pi by 2. Okay. So
if we write in terms of x and y,
omega r into omega 2 here into cos of theta 2 plus r into sin of theta 2 plus
here here is angle
theta 2 plus pi,
because here is x into I into this theta 2 plus pi by 2,
so it is equal to theta 2 plus pi by 2 plus r into sin of theta 2 plus pi by 2 plus L into omega 3 into cos of theta 3 plus pi by 2 plus I into sin of theta 3 plus pi. Okay.
now if we take the terms of I, means if we separate out the real term and imaginary term, then we will get
R into omega 2 into cos of theta 2 plus pi by 2 plus L into omega 3 into cos of theta 3 plus pi by 2 plus I into R into omega 2 into sin of theta 2 plus pi by 2 plus L into omega 3 into sin of theta 3 plus pi.
so this is the equation
Now, what this shows, this is the velocity of the piston. Velocity of the piston. Here is also velocity of the piston has a two terms, that is imaginary term and real term. This is a real term and here imaginary term is absent, means imaginary term is equal to 0. Okay. If we compare the real term and imaginary term of this equation, that is equation of Vp, we will get, first of all we will compare imaginary term. Compare imaginary term. If we compare the imaginary term, we will get r into omega 2 into sin of theta. Theta 2 is 40 degree. 40 degree plus pi by 2. What is 40 plus pi by 2 means? Pi by 2 means 90 degree. 90 plus 40, that is equal to 130 plus L into omega 3 into sin of theta 3. Theta 3 is equal to 250.765 plus 90 means 440.765. Okay, is equal to, imaginary term is absent, therefore it is equal to 0. What is the value of r? R is 0.05 into omega 2 is 100 into sin of 130 plus L is 0.2 into omega 3 into sin of 440.765 is equal to 0. Therefore, omega 3 is equal to 5 into sin of 130 divided by 0.2 into sin of 440.765, and therefore omega 3 is equal to, the value of omega 3 is minus 19.405 radian per second. This omega 3 is equal to minus 19.5, means the angular velocity of connecting rod. This is the angular velocity of the connecting rod, and this minus sign shows that the angular velocity of the connecting rod and the angular velocity of the crank is the same direction. And by using, this is the imaginary term and this is the real term. This real term is equal to velocity of the piston. Therefore, Vp, velocity of the piston, is equal to r into omega 2 into cos of theta 2. Theta 2 is 40 degree, that is equal to 130 plus L into omega 3 into cos of 440.765. R is 0.05 into 100 into cos of 130 plus 0.2 into omega 3 is minus 19.405 into cos of 440.765. And if we solve this, we will get velocity of the piston is equal to minus 3.836 meter per second. This is the velocity of the piston, and here is minus sign. Okay.